Hello my dear students, this is Akash SD. Welcome to the SD Physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Mechanical Properties of Solids and Thermal Properties of Metals, both combined. Okay, so let's go through the question and let's see the question. So see, a metallic bar of Young's modulus 0.5 into 10 to the power 11 Newton per meter square and coefficient of thermal expansion, this one, length 1 meter and area of cross section 10 to the power minus 3 meter square, is heated from 0 degree Celsius to 100 degree Celsius without expansion or a bending. Very, very important, without expansion or a bending. The compressive force developed in it is how much? Okay, students. So here, remember that here, first I'll note down the data. So what is given here? For example, if I write here the Young's modulus, it is given here, see, 0.5 into 10 to the power 11 Newton per meter square. Okay. After that, if I write here the coefficient of thermal expansion means alpha, how much is given? 10 to the power minus 4 degrees Celsius inverse. Even you can write 10 to the power minus 5 Kelvin inverse also, no problem, because the scale is same. Even means temperature difference in Kelvin scale, degree Celsius scale is used to be the same. Okay, that's why we are writing basic. After that, what is given here? Length 1 meter, length 1 meter and area of cross section of the rod, how much is given here? See, 10 power minus 3 meter square, and main thing is the temperature delta T, change in temperature, that means T2 minus T1. How much here? 0 to 100, that means 100 minus 0 means how much here? 100 degrees Celsius. Change in temperature means even it can be 100 Kelvin also. And what we have to calculate here, students, we have to calculate here the force. Which force? Which force they ask here? The compressive force. Okay, so see the question very well here. Okay, so now students, we will just written all this data and all that here. Okay, now we will see the story. What is the story? So story is what here? One fixed end is here, and here also, students, one fixed end is this. Okay, and here we have one rod. We have one rod. The rod is not going to bend and all that. Okay, so students, remember that here, this rod, this is the cross sectional area A. Okay, and as you know very well, the length is L. Okay, so you know what will happen at here? The moment when you will increase the temperature of the rod, that means what will happen? It will try to expand. It will try to expand. So in that situation, because of the expansion, there will be the one force will act because of the expansion, that is called F external. I am writing this is coming because of the expansion of the rod, because temperature is increasing. Okay, but remember that in the question they told that the rod is not allowed to bend and all that. Okay, so what will happen that here, this external force should be nullified by the one compressive stress. Okay, so this compressive stress means F internal. What is this here, students? Here F internal. This internal restoring force will develop into the rod to nullify this external force. Okay, I hope so you understood very well. If in case you are decreasing the temperature, then situation will be reverse. Okay, so I hope so this is very, very clear to you. Now remember that here, the formula is what? We know that this Young's modulus formula is given by stress by strain. What is the formula? Stress by strain. So stress is given by the internal force by area, and strain is given by what? Change in length by original length. Okay. After that, what will happen? That I am just telling you the basics. So y equal to, we can write here, see, F in by A, and maybe I told you na, this question belongs to the thermal properties of metal also. So this delta L we can write here L alpha delta T also. Okay. So from here delta L by L, how much here? Alpha delta T. How much here, students? Here alpha delta T. Okay, so when you will simplify this internal force will come here YA alpha delta T. If in case they ask the stress, that means internal force by area, it will be Y alpha delta T, but here they are asking the force. So this is the formula. Okay, formula I have to remember that. Now we have to put the value YA alpha delta T. Y I remember somewhat, 0.5 into 10 to the power, let me check here, 10 to the power 11. Okay, and A value, how much is this? 10 power minus 3. Okay, so 10 to the power 11 into 10 power minus 3 into alpha value, how much is given here? See, 10 power minus 5. We have to just put the value now. 10 to the power minus 5, and temperature anyhow was the 100 that means 10 to the power 2. Okay, so when we'll simplify this, what will come? 0.5. So here we can tell minus 3 minus 5 means minus 8, and here 10 power 30, 11 plus 2 13 into 10 power minus 8. Okay, so we can write here, see, 0.5 into 10 to the power how much here? 5. 13 minus 8 how much here? 0.5 into 10 power 5 Newton. Now 0.5 into 10 power 5 Newton. Let's check the option here. 0.5 into 10 power 5 Newton. What we are getting here? See, 0.5 into 10 power 5 Newton. Is it? Can you check one more time? Calculation is all correct only? Yes. Okay. Maybe I am getting the doubt somewhat in alpha and all. But okay, 0.5 into 10 power 5. Okay. Great. So now students, if we will check here, 5 into 10 power 3 means it is not matching. Anyhow, this is not the option. So here, if we see here, no, because 5 is this. So when you will simplify this, it will come here how much here? 50 into 10 power 3 Newton somewhat. Okay, that means which option is correct here? You can see very well, students, here the correct option is here option B. Okay, students. So I hope so. This video you have understood very well. Keep studying, keep going.